and we're going to try to find the inverse of the formula. The formula we had was this. The mass at any time t, and this was for this isotope with radioactive decay, was the initial amount times 1/2 to the little t over 25, the length of the half-life. Look at this formula and tell me why they're the same thing. Why are those two formulas considered identical? Because a negative exponent would be take the reciprocal of the base, which would make it 1/2. In some fields of study, when you have decay, you will see a negative exponent, but the base will always be a number bigger than 1. And in other fields of study, when you have decay, you'll always see a fraction in the exponent. So make sure that these sorts of things don't confuse you. They're the same thing. So how do we find the inverse of a function? Well, let's try taking this function, mass remaining is equal to 24 times 2 to the power of negative t over 25, and let's find the inverse, aka exchange m and t and solve for m. That is, t is equal to 24 times 2 to the negative m over 25. So what are we doing here? We are finding the inverse. So we start off by isolating our exponential. T over 24 is equal to 2 to the power of negative m over 25. Solving for a variable and an exponent, we're now going to take the ln of both sides. A ln is a log. So ln laws, log laws, same thing. I've got the ln of t over 24 is equal to negative m over 25 times the ln of 2. Solve this for m. I multiply both sides by 25. And let's divide both sides by negative ln 2. So I've got 25 times the ln of t over 24 divided by negative ln 2 is equal to m. So that's the inverse. So we would say not m is equal to this, but now m inverse of t is equal to, we'd say t at this mass is negative 25 times the ln of m minus the ln of 24 all over the ln of 2. So when will the mass be reduced to 5 milligrams? Now you're just putting 5 in for m. And if you plug that all in your calculators when you get home, you should be getting 56.58 years. And then I'm going to let you practice graphing a ln function. By the way, a ln function inverse of e to the x looks like this. And from there, it's just transformations. For your homework, would you do all the homework questions except for the ones that refer to inverse trig?